Good day everyone. Today we'll be discussing another past board exam problem in civil engineering licensure exam. This is from geotechnical engineering, stresses in soil. So we have a problem. A thick layer of saturated clay has a moisture content of 59%. The specific gravity of soil solid is 2.68. The water table lies on the ground. What is the density of clay in gram per cc? Next is what is the density of clay in what is the effective stress at a depth of 30 meter in kPa? Next is the total stress at the depth of 30 meter in kPa. Now we need to establish what are the given. So it states that it is a thick layer of saturated clay. So meaning if it is saturated, then we have S is equal to 1.0 or 100% saturation. Next, it has a moisture content of 59%. 59% or 0.59 in decimal. Next, the specific gravity of soil solid is 2.68. Next, the water table lies on the ground surface. So meaning it concludes that our soil is saturated. So number one, what is the density of clay in gram per cc? So we have a formula for density that is equal to rho is equal to G plus E over 1 plus E times the density of water in gram per cc. So this is saturated density since our soil is saturated. Okay, so we have the G, we don't have E. So from our relationship between G, MC and SE, we have G is equal to 2.68, MC is 0.59, S is 1.0, E is unknown, therefore E is 2.68 times 0.59 over 1, so 1.5812. So substituting it here, we have 2.68 plus 1.5812 over 1 plus 1.5812 times the density of water in gram per cc is 1 gram per cc. So rho, therefore saturated unit rate is equal to 2.68 plus 1.5812 1 plus 1.5812 times 1. So that is 1.65 gram per cm cube, which is equivalent, which is letter A. So there is no other choices that is nearest our answer, so we'll choose letter A. Next, what is the effective stress at the depth of 30 meter? So actually we can solve first for our total stress at a depth of 30 meters. So when we say total stress, it is in kPa, we can say that stress or pressure is equal to unit weight times the height. Now it is stated that we will get the effective and total stress at a depth of 30 meters. So from the surface, let's say this is point A, this is 30 meters. What is the total stress? The total stress is just equal to unit weight saturated times the height. Now take notice, unit weight saturated shall be in kilonewton per cubic meter. So if we will get the saturated unit weight, it is just the same as here, but we'll just change the density into unit weight. So G plus E over 1 plus E unit weight of water. So 2.68 plus 1.5812, 1 plus 1.5812 times 9.81. So saturated unit weight therefore is, this is part 3 part 3. Saturated unit weight is equal to 16.195. kilonewton per cubic meter. Now if we will substitute it here, that is 16.195 times 30. The total stress is equal to 485.85 Hpge. So that is equal to, that is letter C. This is 485.85. So next part 2. So for our effective stress is just equal to total stress minus the pore water pressure. Now the total stress as already calculated is 485.85. Now the pore water pressure, that is the water pressure from the ground surface up until 30 meter below ground surface. So that is 9.81, or the unit weight of water times the 30. So effective stress is 191.55 kPa. So that is letter B. So that's it. Thank you for listening. You can screenshot the solution now.